Hello, everybody. How are you? It's 7 o'clock. I'm going to go ahead and start. I think I started to record this. I hope it's recording. Let me see here. Pause going to start. Yeah. Okay. So it looks like we're recording. I'm not going to keep you long tonight. Listen, I prepared a bunch of statistics lectures, and when I sent the announcement out this week, I gave you the two that are relevant for this week. And I went back and listened to them. I did those 6 years ago. So I had to kind of refresh my memory as to what they were about. So I hope and almost beg you guys to listen to the two lectures on statistics 1, linear regression. So I'm not going to do those two lectures because it would take an hour and a half or 2 hours. But I'm going to hit some highlights, and I'm just going to say, here's what you need to know as you begin the rest of the assignments for this semester, because we're all going to be focused on regression. And we're going to start out with simple regression, and then we're going to progress to multiple regression, and then we're going to progress to a more advanced topic called forecasting. So that's the progression of data analysis topics for the remainder of the semester. We're past the ML models and the easy stuff, and we're going to get into regression. I think regression is easy as well. But you really need to listen to my lectures. You really need to understand a few basic things. So I'll highlight them, but I'm not going to get into details. Okay. So what is regression? What are we going to be doing all semester? We're going to be taking different topics and seeing if there's a relationship between these things. Like I always say, if you have children, when the children are young, like in the 7th or 8th grade, you should make them determine if there's a relationship between their school grades and their allowance or something. You know, or their playtime or whatever you decide to take away from them if they don't get good grades. So that's what it is. It's the study of relationships among variables. We're going to start simple. We're only going to use two variables, one that we're really focused on, which will always be the dependent variable, and one where we're going to say, how does this influence what we're really focused on? And so very important that you grasp this, and we'll go through simple regression this week and next week, and then we'll pop over to multiple where things get a little more complicated. Also in my lecture, I talk about this idea of the algebra of lines. I'll just show you a couple of slides briefly on that tonight. It's hugely important, right? Y equals mx plus b, where m is the slope of the line and b is the y-intercept. And why is that important? Because, if we can take and have enough data to build a line, and we have confidence in the line, it doesn't have a lot of error in the line, what we can do then is we can forecast the future. We can predict the future, what might happen. And that's extraordinarily powerful. And it all revolves around this idea of y equal mx plus b. So you really need to listen to the two lectures to make sure you got this. I'm not big on the math of statistics, but I am big on sort of like the basics and the concepts, right? Now we'll flip, for regression, we'll flip the y equal mx plus b around a little bit. And we'll do like y hat equals the y-intercept first, plus the slope, which will be b1 times x. And we'll get into that, but that's neither here nor there, right? That's stuff you need to know. And then, but what you really need to know, and I'll go through this briefly tonight, is you really need to know whether your regression model has error in it and how much error. And if your regression model has very little error, that means it's a very good predictive tool. But if your regression model has a lot of error, then you can sort of take it with a grain of salt because there's a lot of error built associated with the model. And that's called the sum of squares concepts, which again, I talk about in nice, comfortable detail in those two YouTube lectures, right? So the sum of squares concept is really important for you to appreciate. And I'm not going to spend a lot of time on it, but I am going to briefly flip through those two ideas tonight. So now, first thing we do when we do a regression of any kind is we ask ourselves, is there a relationship between these variables? For simple regression, it's kind of easy because you only have to do one scatter plot, right? Because you only have two variables, right? So I want to see if these two variables are related. When you get to multiple regression, you kind of got to do a scatter plot between your dependent variable and all of your independent variables. So you do multiple scatter plots, a little bit more work, but with a statistical package, it's just a snap or a piece of cake, right? So you've got to run a scatter plot. If you wind up after running a scatter plot and your data is just all over the place, looks like a cloud of dots, then you can't use regression because it won't work. You don't have a relationship where when one thing moves, the other thing moves in some direction. And so, we do the scatter plot to make sure we've got a regression a linear regression candidate in terms of our variables, right? So, and so it's really easy to do scatter plots in both of our statistical packages, and I'll show you that in a minute, right? Talked about in my lecture, I talk about this idea of the slope and y-intercept of a line. And again, the reason that formula, which we'll flip around a little bit, is really important is because the slope and the y-intercept give us a forecasting model where we can plug in any value, any x, and predict what's likely to happen to the other variable over time. So really important stuff. And again, I'm flying through this now, but in my lecture, I cover it in nice detail, right? So, and so this slide is again taken from the lecture, where for a regression equation, you're going to see a simple linear regression equation like the one at the bottom, where you're going to see what the expected value of y is going to be equal to the value of the slope, the y-intercept plus the slope times the value. And so that equation, you're familiar with this. Y'all had 628. So I'm sure you had a great instructor and the instructor explained all this, right? So just these slides, I just threw these slides in, but I'm not going to spend a lot of time on them, right? Now, the part of what's important about our equation too is being able to understand what we mean when we say error. Does my model have error in it? And so, when you're doing regression, you can have your relationship between the variables can be a positive relationship, which means when your independent variable goes up, your dependent variable follows. Or it can be the inverse. When your independent variable goes up, your dependent variable goes down. You get a negative slope, and that's what you're seeing here. And on rare occasions, you'll get something that has a slope of 0, but that's pretty unusual. So in my lecture, I sort of talk about examples, and I'm going to show you these examples in a minute. And then we're going to end up tonight. I'm going to talk about the problems that are due this week, right? So in the example in my 2 lectures, I use the idea of being able to say, if I know the bill amount of the meal, the price of the meal, can I predict how much the waiter is likely to receive in a tip? And that's the whole idea of my lectures, is to be able to see if there's a predictive aspect to how much a person pays for their meal and how much of a tip they leave, right? So we had some, I'll show you the data in a few minutes, but I only have six data elements, or six points in time. I have meal 1 where the tip was $5, and meal 2 and was 17, and meal 3 was $11 tip. So these are the tip amounts for 6 different meals. Observations, only 6 observations, right? So because I'm not looking at the bill amount yet, I'm only looking at the tip. If I were to plot the tip amount, it's going to have a slope of 0. And you can see these data points there. Data point 1, you can see that little red dot right here is right at $5, right? So there's my first observation. Then my second observation is $17. And my third observation is $11. And my fourth observation is $8. And my fifth observation is 14. And then I get to an observation of $6, right? And so those are my data points, right? So if I run a scatter diagram through those, because I've only got one variable, the slope's going to be 0, right? So you can see it's a horizontal line. And then if you were to average the 5, the 17, the 11, the 8, 14, and the 50, I sit down and just do your averaging or use Excel, you're going to find that the average tip there is $10, right? So that's what the line through the middle is. It's the mean. It's the sort of the mean of that tip. Now, I'm telling you this for an important reason, which we'll get to in a second. We got to get to this concept of sum of squares. So now, if I were to take the distance from the mean of each one of those tips, like if the average is $10, so the first tip of $5 is -5. It's $5 less than the average, right? And then the $17 tip is $7 more than the average. So you can sort of see this. Now, those you see those maroon lines there? Those are really important because that's what we call error, or residual error. The residual and error is the same word. Okay, when you see the word residual, it means error, right? And so this kind of like tells us how much error that we have. So if you add up the numbers above the line, you're going to come up with the number 12. And if you add up the number below the 9, you're going to come up with the number -12. It's just always going to be that you're in a plot of a single value. It's always going to be, it's going to zero out. So
your positives and your negatives are always going to zero out because you did an average line right through the middle. And so it's always going to zero out. So, I'm asking myself, these data points, how far are they from this line that I've plotted, this middle line? And that tells me how much error I have in my model. The closer these dots are to the line, the less error I have. And the further away these dots are from the line, the more error I have. And so how can I quantify the amount of error in this model? Well, I have a little problem. And the problem is if I add plus 12 and minus 12, I'd say 0. So I'd say there's 0 error in the model. And we can't do that. It's just, it's not useful to us to say the error is 0 because we know that there's error here because these data points are away from the line. So there's error in this model. And so we use this concept called sum of squares. And so all we do is we take the tip amounts and we sum them, right? We take them to the second power, right? So first tip of 5, we take to 25. Now a minus times a minus gives me a positive. And that's what we're trying to do with the sum of squares, get rid of all the negatives. So I get 25. And then I 7 times 7 is 49, it's positive. 1 times 1 is still 1, positive. 2 times 2, negative 2 times negative 2 is a positive 2. 4 times 4 is 16. 5 times 5 is 25. Again, explain all this in my lectures a lot slower, right? And so then if I add up the sum of squares, the residual, we call the residuals or the error, I come up with a number 120, 25 plus 49. Plus 1 plus 4 plus 16 plus 25, and I get to 120. And that's the number. When you run a regression, you're going to get this residual, you're going to get this sum of squares error every time you run a regression. And what you all have to do is be able, and I'll sum this up at the end, is to be able to say how much error is in your model. And so we'll get to that, right? So we'll get to that. But these are the mechanics behind this concept when we run a regression. Get one of the data points, one of the things that we get back is how much error is built into the model that we get. Another thing we get back is we get our equation, y equal mx plus b reversed, and that's our predictive tool. So when we do a regression, we get a lot of useful things back. So I just wanted to do that sum of squares because it's just really important because what you do is when you sum up the squares, you get your residual number, your level of error in your model. Okay, so it's very important. So listen to the lectures. The first lecture covers this, and then the second lecture that I sent out on the announcement on Monday is about how to do the regression itself, right? So just listen to this background. Won't take you long. I told you before, I have students from all over the world that think that I've done a nice, simple job with this, and I have followers from all countries and all kinds of colleges and universities trying to understand statistics because their teachers are too quantitative. They're just making it too number oriented. And I'm not about the numbers. I'm about the practicality of using statistics. So there it is. This is very important. This is how much error is in my model? What is my SSE, the sum of squared errors? For this particular model, it's 120. And what does that mean? Well, we'll deal with that later. Okay, so this is what we're trying to do. I just wanted you to understand that. I just flew through that because I wanted to make sure you go back and listen to my lectures and you make sure you get this because it's really important. I mean, listen, if you ever are working for someone and you're trying to do analysis for them using regression, you got to be able to explain things. You got to say to them, here's the forecasting equation, and you tell me what number you want me to plug in, and I can tell you what the answer is. But you also got to tell them how the goodness of fit, how good this model is, what the quality of the model is. Also, you have to be able to, and we'll get to this later in the semester, try to make your model better. Now, when we get to multiple regression, we can do that. When we're with simple linear with only 2 variables, yeah, it's a lot harder to make your model better. But we'll get to that. And so you as an analyst trying to be able to say, I ran a regression and, I'm not satisfied with the level of error in this model. I'm going to try this to see if I can make that level of error go down. That's really important stuff in statistics. That's what makes you seem like a good analyst, right? So end of discussion of error. I'll bring it up in a second, but that's the big thing. So what are we trying to do this week? I got 2 problems for you. In those 2 problems, there's 2 variables. There's a dependent variable and independent variable. And I need for you to run a regression on each one, and I need for you to interpret the results, right? Pretty simple job. At the end, when I get done here, a couple more slides, I'll go over the problem for this week. But right now, I'm just still staying with my lecture model or framework, right? So, okay, so in simple linear regression, we're just trying to model relation. Simple means 2 variables
a dependent one, which is what we're focused on. I want to see what happens to this thing. I want to see how this affects that, right? So the independent variable is the influencer, right? So the dependent variable is your main thing. There's always usually only one dependent variable. You're just focused on, I want to see how this changes when these other things change. So it's your main thing. Objective is to develop the best possible model. And so what I just covered, this goodness of fit, is used to assess how well a regression line fits the data points it represents. And that's that SSE number, right? And I'll show it to you in a second. And then once you get the best possible model, then how do you read the stuff that comes out of statistics? How do you know what to do with it? And then how do you use the results for some purpose? Okay, so that's the gist of my lectures, and I hope to take some time. So as I said before, what you should do this week on these models that you have to do is develop a scatter plot, right? And scatter plot just lets you see the relationship between these two variables. When you first start out, you don't know what the relationship is. You can eyeball the data and you can say, well, it kind of looks like, you see on this little call out box on the right-hand side here, you see this, right? So you look at this, and then this went up and that went up, and you can say, well, I think there's a relationship, but you don't have a quantitative basis for that. You had to run a scatter plot on your data all the time, right? And then, and it's a lot better when you have a line running through those dots, right? So this just shows you the line running through the dots. So I'll talk about that in 1 second. I'm going to show you the two packages tonight, Stat Tools and SPSS. Okay, so and then what you get if you run if you run this in Excel, which you can, like a scatter plot, you don't get a correlation coefficient, right? And correlation coefficients are extremely important. 1 and -1 are really high correlations. Things are really strong. They move strongly together. At 0, correlation coefficient means there's no relationship between these things. They're random. And so you can see when I ran a scatter plot against this in Stat Tools came back and said the correlation coefficient amongst these two variables is 0.866, getting close to 1, which means, yeah, they tend to move together. When the bill amount goes up, the tip tends to go up, right? So that's useful to know as well. Do you have to have a correlation coefficient? Not really. I mean, you can eyeball this thing and say there's a linear relationship, but the correlation coefficient is data, and it helps you kind of reinforce that. You don't get that in Excel. You would only get that using a more advanced package, right? What does this mean? Okay. Descriptive statistics, the best fit regression line must pass through the centroid. Now I'm going to skip that. It's not important for now. This is, again, the regression equation that you're going to get out of your model. And you just really need to appreciate that. Again, y'all had 628, so you know this stuff. And I don't want to skip by this, but I covered this in my lecture because it really shows you how that regression model works with the sum of squares, et cetera. And so it's really kind of a cool thing to see how all the numbers work. The X being the total bill amount and the Y being the total tip amount. And then at the bottom, you see the average. The average bill is $74. The average tip is $10. And then I start using my averages in my formula, which is Y equal MX plus B inverted, to be able to actually calculate a number that is very useful for me. And we'll see that when it comes out in your regression output. So, okay, so boop. So when you run the regression equation for the data, I just used the 6 observations of bill and tip. You get this answer, and I'll show it to you in a second in the regression output, right? And so this is really important this week because you're going to get an equation, and you have to be able to interpret it for me this week for your boss or whoever you're doing the work for. I'm pretending to be that this week, and so you have to be able to say, for every dollar that more that the bill increases, the price of the meal, the tip's likely to go up 14%. It's my predictive amount. And then you can sort of see that there's an error thing on the right-hand side. I'll talk about that in a second, right? So it's really important that you can interpret, especially that 0.1462. So, boop. Okay, I'll skip that again. I covered that in my lecture. Okay, so I just want to talk to you about how you got to do this week's assignment, right? So you got to use a linear regression. And you got to interpret the output, right? And so we're going to use a package, and I've got both packages ready to go tonight. I'm going to skip these slides because I'm going to show you the real stuff, right? These slides are just showing you stat tools, right? Okay, there's the output I get from stat tools when I run this. Okay, so let me shift out, right? And if you have questions, just kind of like jump in here. Let me shift out here. I'm going to go first to stat tools, which is really, stat tools is just an Excel add-in, right? So I'm going to go over here and I'm going to share the spreadsheet. This is just the data, that file that I give you, right? So this week for your assignment, I give you 2 data files, 1 for each problem, and you have to run a regression on those, right? So if you're going to use stat tools, which it's really easy to do, you bring up your Excel spreadsheet, and then you go to your start menu and you start stat tools, and it becomes a tab. You see this tab up here? It becomes that tab. And so you can see my data over here. Let me just, let me increase the size of that data a little bit. Zoom in a little bit more. Let's go to 125, just so y'all can see it nice and clearly. All right, boop. All right, so data got a little bigger. Okay, so now when you use stat tools, when you open your file and then you start stat tools off the start menu, after you've installed it, you click on the stat tools option on the menu here, and then you see the data set manager on the far left-hand side. For stat tools, you have to do this. You don't have to do this in SPSS. It's different. You have to define so when you click on the data set manager, I've already defined mine, but all you do is you just highlight A2 through B7. That's all you do. And then you click on OK, and your data is now defined to stat tools, right? So you kind of have to do that. So don't forget to do that. I've got the deadly hourglass here, but all right, stop. I'm using a computer. It's really slow. A friend of mine passed away and his wife gave me his computer, so I use this for all my Zoom stuff. Let me close out of this. Okay, so that's the first thing you have to do if you're using stat tools. And again, I cover this in the lecture. You have to do your data set manager. And then after that, you're just going to come over here and you're going to do 2 things. One is under summary graphs. You're going to pick a scatter plot. See that? Right? Boop. Where'd it go? Scatter plot. You're going to pick scatter plot. Oh, and it did that. Well, let me see here. I'm going to delete this out. I'll do it again. I can't be sure that this isn't something that already was done before. Delete this out. I want to do this from scratch. So I'd already done this for the lecture, but okay. So if I go back to my thing now, okay. So if I go to summary graphs, scatter plot. Okay, so it comes up. Now, remember, you got to know your dependent variable and your independent variable. If you do these backwards, you're going to get wrong numbers and you'll get points off on your grade. So what is the dependent variable? It's the thing you're most interested in. And in this case, I was interested in what's going on with the tips, right? And so, but I've already told you for the 2 problems you have to do this week, I've told you what the dependent variable is, the main thing, and what the independent variable is. So just make sure you don't mess those up here, right? So you can see where it says X is the bill amount, Y is the tip amount. We always plot the dependent variable on the vertical axis. And we always, in simple regression, the X value becomes on the X axis. So, and so I just got to click those 2 boxes because it's got the bill amount and tip amount. And you see it's a box at the bottom says display correlation coefficient. And there's a format button here. Unstacked is what it should be. And you click OK, and hopefully this thing will run a scatter plot. Okay, so it ran a scatter plot for me. And so you can sort of see that's kind of how it comes out, right? So it actually created in a different workbook. Which I hate about this, but anyway, so there it is. There's your scatter plot. You look at the scatter plot and you say, yeah, I've looked at the scatter plot and everything looks fine. It looks like this data is linear. So then the next thing we'll do after you do in stat tools, after you do your graph, is you just come over to regression and you run your regression. Boop. And the same thing, you got to make sure that your independent variable is the bill and your dependent variable is the tip. Why? Because we're focused on the tip here. And you go ahead and you can run your regression and you'll get a regression. Boop. And so somehow, somewhere, you'll get a regression. Okay, so you see these values, right? You get the down the bottom, the constant 0.8 minus 0.82 and bill amount 14.62 cents. Remember I said before, I'm going to show you this all doctored up. I'm going to tell you exactly what everything on this page means. But I just wanted to show you that's what you got to do for this week's assignment. Okay, so that's stat tools. And I'm going to get out of this. So if you have any questions, I'm going to help you. But okay, now, if you decide, if you're using Macs or whatever, and you decide to use SPSS, you got to install SPSS using the procedure I gave you. Actually, you got to go to the My U-Ball, and down the lower right-hand side, it says SPSS, and you got to install it. Okay, so I've got this installed. So I just opened up SPSS. Now, SPSS doesn't have Excel data in it. You got to do something a little different if you're using SPSS. I will say to you, I tried to use SPSS about 6 years ago. Really hard to use. But SPSS right now is much, much easier. So, so go ahead, Mo, go ahead. What do you, is there a question?
Yes, hi.
You
If
have a
you're
question,
sharing,
Maggie?
can you hear me?
Anybody have a question? You got your hand raised. Okay. If you have questions, just jump in. Okay, just say, I got a question. All right, so for SPSS, you got to go file, open, file, import data. This is what you got to do because the data is in Excel and this is SPSS, which is why I like stat tools, because in stat tools, you stay in Excel and you just put another tab up and add in. But with SPSS, you got to do this. So I'm going to import an Excel file, and then it's going to want to know where that Excel file is. And so I got to prowl through my hard drive. I use Dropbox. I put this file out here this evening on, on number 5, and it's called regression example. So I'm clicking on regression example. You see that, right? So I just found my file. I'm going to open it, and it's going to bring the data in. Boop. So it'll be just like it was in Excel a few minutes ago with stat tools. Yeah, you know, you got to do all this stuff, but boop. So there it is. Okay, so it looks.
Hello,
just like,
Professor. Can you hear
like
me?
stat tools looked, right? Are you all able to see this? Let me make sure I'm showing you the right thing here. Maybe I'm not showing you the right thing. Here. Hold on a second.
We can't see it.
Yeah, we can't
Maybe this is
see.
what your question was. Y'all see that? I'll try that
No.
again.
Oh, here it is.
Dag. Let me undo. So what you do is you got to do file, import data, Excel, and then you go to wherever the data file that I gave you is on your computer, and you import it into SPSS. Okay, everybody see this now? Sorry about that. I got to remember, because I think you're seeing everything I'm doing, but you know, I got to remember when I switch to a different tab, you've got to be able to see what I'm up to. So, okay, so here it is. So same kind of thing I got to do here and for SPSS, it's still basically, you got to run a scatter plot. So you go to graphs, chart builder. Don't show this dialog again. I just installed SPSS on this computer a minute or two ago, actually this afternoon. So I don't know what's going to happen. Okay. So I see I got my 2 variables up there, my bill amount, my tip amount. So down at the bottom, you can see all the different options I have for graphs. What did I say I want? I want a scatter plot, right? So I come down here and I click on scatter. I grab this one that has all the dots on it, this top left one, I drag it up here. Kaboom, right? And so I'm going to get a scatter plot, and then I got to build my y-axis and x-axis, right? So remember, the dependent variable, the thing you're most interested in is always going up, right? So I'm most interested in tip. So I'm going to put tip over here. Boop. I'm going to drag bill over because that's going to be my independent variable, bill amount. And then one other thing I wanted to say, you see on the right-hand side down the bottom where it says linear fit lines, I'm going to click on total because I want to see the line, right? And so I always click on that. So now I hope this works. Scatter plot, tip amount, set color, set size, filter, blah, blah, blah. Okay, so let's see what happens here if I run this. All right, so there it is. All right, and so, you know, you can see it. I did give you my line dag. But anyway, you can see it. It's the same kind of scatter plot that I got out of Excel. Save contents over. Yeah, I don't want to save contents. Okay. So there was a box I was supposed to check on. I thought I checked on it. That gives you the line through it as well. Okay, so that's number 1. And then number 2, after you do your graphs, is you got to do your regression. And so I'll do the regression in SPSS. I want to do linear regression, right? So I'm doing regression, analyze, regression, linear regression. All right, so there it is, right? What's a dependent variable again? It's tip. What's the bill amount? The independent variable bill amount, right? Boop. Okay, so that looks pretty good. So let's run a regression and see what happens. Boom. Okay, so I get a regression. It looks a little different, but if I scroll down to the bottom, I still see the bill amount 0.146. Remember I said to you before, you know, if the meal amount goes up $1, the tips likely to go up 14.5 cents. So I got the same data out of this one that I got out of the other package as well. So anyway, I just want to give you a quick overview of SPSS if you're going to use that tonight too. But you can use either one. I mean, perfectly fine by me, which one you use. Okay, now I'm going to go back to my slides because now the most important slide of the whole evening, and then I'm going to let you go. Let me get back here. Share. Boom. Okay. PowerPoints, right? So I got this data out of either StatTools or SPSS. It doesn't matter. It's all there. Trust me. Everything that you see on here is in both outputs, right? It just might be in a slightly different location, but it has the same titles, right? So now what you need to do is be able to figure out what this says. And again, y'all had PUAD 628, which my wife teaches. And so you know this, right? But Dr. Kessler has lectures about this. And in his second of those 2 lectures, he covers this in great detail. And so this tells you in excruciating detail what everything on a regression output means. And this is what you have to explain when you do these problems this week, right? So we have the coefficient of determination, the amount of variation in the dependent variable that is explained by the independent variable, right? And so what do we want with the R squared? Do we want a big number or a little number? We want the bigger the better, because we want our model to explain as much of the change in values as possible. And what this R squared tells us for the bills and tips is that that the relationship between the bill amount and the tip amount can be 75% explained by this model. We can explain 75%. So you ought to, your thinking hat's on. What's causing the other 25%? And we'll talk about that later, right? But this is just, if the bill amount is this amount, the tip amount is this amount. That's the model, 75%. Okay, now the adjusted R square, for now, we're not going to use it. When we get to multiple regression, we'll use it. But both of those are good numbers. Anytime you get to a 75.75 for an R square, you got a pretty good model, you know. And so you can see the range of error. I explained that in my lecture too. Not going to talk about it too much tonight, but that's a good number, 2.74. You can see the p-value if you come down to C on the right-hand side. You know, you always want a p-value of less than 0.05. And in this case, the p-value of this model is 0.0259, which says, yeah, this is a pretty significant model. The significance level is reasonable. If that p-value was like 0.67, this would not be a good model. It would, and your scatter plot would reflect that. Okay, now you come down to, now this, I want you to notice here at the very top in the StatTools report, I'm told that the variable that I'm analyzing is the tip amount, right? So you see that up there. And so that's important because that's one of your 2 variables. So now you can look at how much error you have in your model. See that F here, it says sum of square of error, SSE. That's where you took the variation and then you squared it and you summed it together. And I can tell you that 30 is a really low error level as error levels go. It's a good number. And it just fits with all the rest of the stuff in this model. So then you come down to our equation down here, and you just had to kind of like, you know, you have to have this equation in your head, right? You ought to have a pencil, and you have to know that y hat is equal to in this case, the slope times x, right? The slope times the error, which is 0.1462, which we got in both of our models, right? So what that basically tells us that slope is, as it says underneath of it, for every $1 that the bill amount goes up, because this is the bill amount number, the coefficient, meaning the other variable, goes up 14%. And it's positive. It means they go up, right? If it was negative, it would mean if the bill amount goes up tip amount goes down, but that's, that's not logical, right? So we got a positive number there. If I had a negative number, it'd be an inverse relationship, but this is a positive direct relationship. And so there's other things explained in here as well. I'm not going to get into it again. You all have had stats course and stuff, but this is really, really useful. And so, I hope that you keep this, you print out this page somewhere along the line and you use the page and when you're doing your analysis, that you're able to articulate things based on the output you get on your regression model using these red things that I've sort of characterized here. Okay, so that was a big thing I wanted to show you tonight. I wanted to show you this page. And so what we conclude in this problem here was our coefficient of 0.7494, 75% of change. Why might we have what other factors might weigh into the change other than the bill amount? Well, it might be the quality of service, right? Your tip might go up or down, like they didn't bring your water when you wanted some water. It might be a couple other things that it could be, but it could be a number of factors that make people tip not exactly the 15% or 18% or whatever it is. So, the equation is a useful equation for us. It predicts a tip increase for every dollar in the bill amount. And so we can use that equation to say, if my bill is this amount, what's the tip likely to be? Very useful tool for some of these folks here. I'm not going to get into range of error. This I talk about that in my lecture, but that's what one of the values on that output was a few minutes ago. It just shows you the range of error, and I do a pretty good job in the lecture explaining that. So what do you do with this, right? So you can say that there's a strong relationship between the price of the meal and the tip, right? Being factual, right, to 75%. For practical management perspective, the owner can add the total bills for a given day and estimate how much tips you're going to give to the staff, right? That's useful. You could add the waiter name to each data point and look for patterns, right? Which one of my waiters are getting below the line? Maybe I need to get me a new waiter, waitress, whatever. And so there's other things to consider. Oh yeah, this is since the bill amount, the service quality is one thing. Other things, some people are just cheap. Some people are just like, nah, I don't leave much tip. I give them $1. My wife always says, leave them $1, leave them a whole dollar, right? And I'm a big tipper, right? So we always get into that. Okay, and so anyway, that's the big deal for tonight. And I hope that was helpful to you. We've been here 37 minutes and I only like to do 30 minutes on these things. So, okay. So for this week, you got to do 2 problems, right? First problem is simple regression, just like we just did, same old, right? And you got to explain it, right? So you just got to run a regression using either stat tools or SPSS. You got to take a look at the average farm size. And you're trying to say, I wonder if how many farms we have determines the size of the farms. That's the question, right? And so that's what you're investigating, right? And so I'll give you data. It's a data file that's sitting there on Sakai. And so all you do is just download the file. You either open it up in Excel because it's already in Excel, and use stat tools or import it into the Excel file into SPSS, and then go to town, right? Run your scatter diagram. Take a look at these variables. I mean, I can assure you there'll be somewhat of a linear relationship or we wouldn't be doing this, right? And then run your regression model and then take the data that you get back and using that stuff we just went through, interpret it, see what you can do with it, right? So that's the thing. And so, and then 1-3 here, this is right from the assignment. Identify at least one potential federal policy implication based on your analysis. How would this be useful to a policymaker, right? What could you do? And so that'd be fun. I always like to see those answers. Those are more interesting to me than your spreadsheets, right? And so the second problem you have to do tonight, and then there's one of these next week, a little more complicated, is look at the relationship between the daily temperature and the peak power load. So, if you're in charge of your utility, you want to know, like, can I predict what temperature is and how much demand will be for electricity on that day? Very useful kind of thing, right? So, and so that's it. So you got 25 observations for the summertime. You got to do a regression analysis on the data file. You should always do a scatter diagram, just run it to make sure, just to take a look at it, because it's useful. It lets you see visually like what things look like. So you get to run the regression. We're most interested in what the demand will be, right? And so our question is, how does temperature affect demand? So dependent variable is peak power load. It's the y-axis. And then do the regression equation. You're going to get it based on the diagram I just showed you. Look at the residuals. What are residuals? It's the error, right? We talked about the error before. Do they suggest the regression equation is good? If not, go back and play with the equation a little bit and see what you can do. 2-4, use your final equation to predict the peak power load on a summer day with a high temperature of 100 degrees. All right, so that'll be fun. It's just plug in 100 for the X, see what happens. And then scatter plot for the data, comment on the observed relationship. You're done. Turn that in. Y'all should be able to knock this out in a half hour, 15 minutes each. Right. So anyway, that's all I have for you tonight. I'm going to stop sharing and see if you've got any questions. Anybody have any questions? Someone tell him, no, I can't see it. Yeah, I'm sorry. I'm sorry about, I forget. But y'all can see the slides, I hope. So everybody good? No questions at all. It must have been a really good presentation.
Question for you. So
Jared, are you good?
just a quick question. So I have
Are
a
you
Mac.
there, Jared?
Can you hear me?
Anybody? Radina? Okay.
Can
Listen, I appreciate
hear-
you being here tonight. I hope this is helpful.
Can you hear us?
This week and next week should be a piece of cake.
I don't think
We
you
get
can.
into multiple regression.
Can
it might
y'all
be a
hear
little
me?
challenging. But listen to my lectures. I got two
Can't
more
hear
lectures
you.
for multiple regression. And I do the same thing. I give you an output of a regression model with big red circles around it. And you got more stuff to analyze. I see you. Go ahead.
Okay.
Can
I
you
can't
hear
hear
us?
you. You must be muted or something. I can't hear you. Oh, maybe my headphones are not on. Hold on a sec. Try it now.
Can you hear us?
Yeah, it's good. My headphones.
Oh man, we've been talking the whole time.
Oh, sorry. My headphones are messed up. Sorry.
No, you good. So I'm one of the people that have a Mac computer. So
Yeah.
when we exported the SPSS, are we leaving it on SPSS and putting it on like the assignment tab, or are we putting it back on the spreadsheet?
Yeah, I don't think you can well, there's a way to take your output and put it back on the spreadsheet. There's a way to get it back on the spreadsheet, but don't worry about it. Just, put up whatever you got. What this thing does is it creates these picture files, right? So you can submit the picture files. So if you submitted like one file is a scatter plot, the other file's the regression output. I mean, I don't need the input data. I got that. Right? Does that make sense? Is that good?
Got
Okay.
Got
If you run into problems, shoot me an email, right? Better to send it to my Gmail first. Otherwise, I check once a day, but if you want a real quick answer, Gmail me.
Yeah.
Okay, good. Yeah. Anybody else? Radina, you good? Sorry about you're muted now.
No, I think I'm good for now.
Okay, good. Well,
For
listen,
now.
if you listen to those two lectures, I had to listen to them too because I hadn't listened to them in 6 years, so I listened to them yesterday, and it's a
Okay.
little bit of time, but I go through it step by step. The most important thing is that one where I mark everything up, because you're going to be able to run a regression. I think if you can't, let me know. We'll do a Zoom session together or something. But once you get your regression output, the challenge is being able to interpret it, and that's why if you print out that one page that I gave you. I've included the PowerPoints on Sakai, so you should be able to print that out and keep that beside you. And it'll be even more important when you get to multiple regression because I got everything circled.
Okay.
Okay, good.
I think I'm good.
Are you good? may not be able to talk to us tonight. So I apologize about the thing. I got these headphones and they got a battery in them, and sometimes I gotta
Hello.
tap the battery. So I don't think he's there. Okay, well, listen, I'll see you guys soon. If you have any issues with these problems, let me know, okay? And we'll